I'm Courtney.
I'm Courtney. Is that working? Yes. I'm a third year PhD candidate in the Centre for Ecosystem Science at the University of New South Wales, and I'm supervised by Catherine Moseby. And the main overarching theme of my whole PhD is looking at extreme heat and how that impacts threatened desert mammals. And so just a bit of background information. So desert ecosystems cover more than 70% of Australia, and they are particularly vulnerable to the effects of climate change. Extreme heat events in Australia are predicted to become more frequent, longer, and hotter under climate change. And this increase in extreme heat may exceed the tolerable limits for many species, and especially those species that are living within these desert areas. And so Australia has a pretty bad extinction record, and this is particularly concerning for our native mammals. Since European colonisation in 1788, Australia has lost more than 30 native mammals to extinction, most of which have lived in desert ecosystems. Currently, Australia still has over 30 native mammals that live within deserts that are threatened with extinction. However, not much research has looked at the effects of extreme heat on our native mammals. So basically, this became my research question. And so my main aim is, how does temperature affect the behaviour and the activity of threatened Australian mammals? And to answer this, I chose the numbat as my study species. And for those of you that aren't familiar with numbats, this is what they look like. They are incredibly cute. They are marsupials. They are endemic to Australia, so they're not found anywhere else in the world. And they are the only living representative of their family, Myrmecobidae. They weigh about 500 grams on average, so they're quite small, and they are diurnal, which means they're active during the day and they sleep at night, just like us. And numbats exclusively eat termites. So they have this long, sticky tongue, and what they do is they dig these little shallow depressions in the soil, and they stick their tongue into the termite galleries to extract termites to feed. And they need around 20,000 termites per day to sustain themselves. So as you can imagine, it's a lot of hard work being a numbat. And so numbats were once found across the vast majority of southern arid Australia, with a range spanning from far west New South Wales, southern WA all the way across to far west New South Wales. And they've had a huge range contraction, mostly due to habitat loss or predation by invasive predators such as feral cats and foxes. And now numbats can only be found in the wild in these two small areas in pink that you can see on the map, in Dryandra and Perrott in southwest WA. And so you can also find numbats in several fenced predator-free conservation reserves across southern Australia, where they've been introduced in an effort to build up their population and protect the species. And these reserves are really crucial for the survival and the recovery of the species, as they provide a safe haven away from predators and away from disturbance that they're experiencing in the wild. However, this isn't a long-term solution. There are plans to reintroduce numbats back into the wild, but normally these reintroductions are informed by the historic range of the species. However, with climate change bringing an increase in extreme heat and extreme hot days, we no longer know if their historic range will be suitable for current or future populations. And so numbats are the ideal study species to look at the impact of temperature. And this is mostly because they're endangered. So there's estimated to be less than 1,000 individuals left in the wild, but also because they're vulnerable to high temperatures. And this is because numbats are active during the day, which exposes them to direct solar radiation, but also because they're not obligate burrowers. So although they do sometimes use burrows, they're more often found in hollows and logs, which are likely to be less thermally insulative than burrows. And so to see if numbat activity is influenced by temperature, we used accelerometers attached to collars like this. And so the accelerometer is this part down here at the bottom, and this part on the side is a VHF, so we can radio track the animals and see where they're going. And what the accelerometers do is they measure speed and movement patterns, and I'll just explain how they work. So this is a numbat with an accelerometer collar on. And the accelerometer takes measurements on 3 different axes. And it generates an output that looks like this. And from this, we can look at vectoral dynamic body acceleration, or VDBA, which is a long, confusing word, but basically it's is a sum of the 3 axes that we're taking measurements of, and it can be used as a proxy for energy expenditure. And so what we can do is we can compare this to data from weather stations and see how temperature and humidity are influencing activity throughout the day. And the other thing we can do is we can break down the output into different behaviours. So each different squiggly line signature represents a different behaviour. And so from this, we can see how the animals are shifting their behaviour at different times and at different temperatures. And so these are my 2 study sites. So we have the Australian Wildlife Conservancy's Mount Gibson Sanctuary in WA and Secret Rocks Reserve on the Eyre Peninsula in South Australia. And both of these sites are fenced, predator-free conservation reserves. And so what we did was we fitted collars to 8 numbats at Mount Gibson Sanctuary and 7 numbats at Secret Rocks Reserve. And these collars were left on individuals for up to 60 days across 2 summer periods. And so this is just a summary of the temperatures across the study period at both of my sites. And so you can sort of see that Secret Rocks had a bit of a wider spread of temperatures, with a lot of temperatures going into that cooler range. However, if you look at the higher temperatures above 35 and above 40 degrees, both sites had similar number of days covering those temperatures. We also saw that both sites had similar maximum and minimum daily maximum temperatures as well. And so what I found from this data was that numbat activity is influenced by temperature, but it's not really influenced by humidity. And so what we're here is humidity, temperature on the x-axis, and then the different colours are the different levels of VDBA, or energy expenditure. So the more yellow the colour, the more energy is being used, and the more blue the colour, the less energy is being used. So as you can see, the preferred band between about 20 and 32 degrees at both sites, but this doesn't really change with humidity. We also found that they like to have a little nap in the middle of the day during summer, which is very relatable. So what we're looking at here is mean energy expenditure on the y-axis and time of day on the x-axis. And you can see that they're using most of their energy in these morning periods and afternoon periods, and they're reducing the energy in the middle of the day when it's likely to be really hot. And then what I wanted to do was compare these patterns with temperature, and this is what I found. So again, we've got mean energy expenditure on the y-axis and time of day on the x-axis, and each different coloured line is a different temperature range. So the darker the blue the temperature, the cooler the temperature, and the darker the red, the warmer the temperature. And so as you can see, as the temperature is increasing, the numbats are using less energy and for a longer duration in that middle part of the day. And this really raises concerns about whether more hot days will prevent the numbats from having enough foraging time to really be able to sustain themselves, which eventually may lead to a loss of body condition or even starvation. And so then back to this slide, because this is the next thing I wanted to do. So looking at those more fine scale behaviours rather than just activity in general. And so I have a lot of these outputs with these different signatures, but I don't actually know yet what each of the signatures represents. And so what I have done is I've gone to Perth Zoo and I've filmed the numbats wearing the collars, so I can match up the filmed behaviours with the accelerometer outputs. And so what we did was we fit 4 collars to 4 numbats in 4 different pens. And then we set up 2 cameras in each pen, and the cameras were set to record 60-second videos every time the sensor was triggered. And I left the collars on the animals and the camera set up for 5 days and ended up with over 2,000 videos and numbats. So unfortunately, I don't have any results from this part yet because I'm still going through the videos, but to be continued. But something else I have been working on is looking at the shelter site choice of the numbats and how this differs with different temperatures. So this analysis was just done for the 7 numbats at Secret Rocks Reserve. So while they had the accelerometer collars on with the VHFs on the side, we spent a lot of time running around trying to find where they were and radio tracking to their shelters during their rest period to see what they were choosing. And so what I did was we identified 345 shelters. And this is sort of how they were split. So we've got basal hollows, which are the hollows at the bottom of the trees with a ground level entrance. A standing hollow is any hollow that has an entrance above the ground. Burrows, which are pretty self-explanatory. Debris piles, which, so when they built the roads and the fences, they pushed all of the fallen trees and logs into piles at the side of the road, which the numbats actually really like to use as shelters. Logs, and then lignotubers, which a lot of the mallees out at Secret Rocks have these big lignotuber root systems that sort of go above the soil, and the numbats sometimes dig little scrapes like deep underneath the root systems. And so there's a pretty big range of shelters to choose from. And what I did was I compared the predicted probability of shelter use, which is on the y-axis, and I compared that to the previous day's maximum temperature. So we're assuming that they're choosing their shelter not based on the current nighttime temperature, but based on the maximum temperature of the day before that night. And so what we can see is that the burrows, the yellow line here, they really like to use when it's cold, and this quite consistently drops as it gets warmer. These 3 lines here are all of the dead trees and the debris piles, which they don't really preferentially choose. But you can see as it gets hot, this blue line, which is a standing hollow in a live tree, and this green line, which is a basal hollow in a live tree, and also the lignotuber roots that they scrape under all increase as it gets hot. And so this information is really important to know the environmental characteristics that numbats need for survival. And so this data can inform translocation sites by showing the different types of shelters that the numbats need and what they're using. And so sites that don't have enough live trees or enough old trees that have those big lignotuber roots are unlikely to be suitable sites for numbats to be reintroduced to. And so to summarize, numbat activity is influenced by temperature. They have a preference for around 20 to 32 degrees. As temperature increases, numbats use less energy and for a longer duration in the middle of the day during summer nap time. Numbat shelter choice is also influenced by temperature. They prefer burrows when it's cool, and they prefer live tree hollows and lignotuber scrapes when it's hot. And all this data is really critical to inform numbat relocation efforts to areas that are suitable for both the current and for future populations under climate change. And I just want to acknowledge the traditional custodians on the land that this work took place, and just a huge thank you to you guys for supporting this work. Thank you.
Well, very interesting talk. In regard to the termites they're feeding on, do they feed on particular termite species, or species that are attacking timber? Do you think they could feed on termites that feed on grassland and the forest thing? And as many desert mammals are nocturnal, is there any opportunity for numbats to be a bit nocturnal in their foraging, or do the termites disappear from being available?
Yeah, so to answer the first part of your question, we've not done any tests on looking at the different species of termites, but numbats don't really seem to live in grassland areas. They do mostly live in woodland areas, so I would assume that they would be sort of preferentially choosing those termites, but yeah, we wouldn't be, sure on that because we've not tested it. But to answer your second question about numbats potentially moving into a more nocturnal lifestyle, a great question, and it's something that we are looking into. So I've started doing some trial studies on looking at termite activity at Secret Rocks Reserve in South Australia. And so we're trying to figure out when the termites stop being active, to sort of see if that is what's driving numbat activity, and to see if, they could move their activity into night. Yeah.
Temperature difference inside the tree lines compared to the outside?
So I have got some eye buttons out at the moment, which are just little devices that log the temperature. And so we've gone and put a lot of those inside hollows and burrows of the different temperatures, the different shelter sites. And so what I'm going to do is then add to this analysis, add the temperature that we're getting from inside of those to sort of see which ones are really thermally insulative and which ones are not, and sort of really dig deeper into why they're choosing those shelters. Yeah.
Just wondering, numbats, do they need supplement moisture? Do they need to drink water, or do they get enough moisture from the plants?
They get enough moisture from their food. They're not often found in places where there's always freestanding water. So yeah, they don't need it.
Have you got any information on their breeding patterns, or just out of interest? I don't know.
Oh yeah, so they breed once a year, and the females can carry up to 4 young at a time, and so they've got sort of like a false pouch. It's not like a true pouch where the babies go all the way inside. It's a little just sort of depression with a bit of a skin flap, and then the babies get quite big, where you'll just see them hanging off the mother before she'll den them. And then they'll stay in the den until they're old enough to start foraging for themselves. And then she'll sort of, hang out with them for a little bit, maybe teach them how to forage, and then they'll all disperse, and because they're very solitary animals. But yeah, just one breeding season per year. Yeah.
So do you think there needs to be a minimum amount of debris in a forest or that floor? And is there any understanding of what would the bigger canopy help be to provide habitat for the numbat? Get dry and high and get starflowers.
Yeah, so we've not looked at I guess trying to quantify that, but there definitely would be some sort of yeah, number threshold of, logs and hollows that they would need, and old enough trees that have those features that they really like for them to be able to survive in those areas. Yeah, it would definitely be interesting to look into.
The termites that they feed on, they in a termite farm, what's the preference?
So numbats are a bit silly, and they don't like digging into the mounds. You don't often see them digging, well, I don't think I've ever seen them digging into the mounds. They prefer to just dig little sort of depressions where you get into the galleries, like the little tunnels that the termites build, or you'll see them sort of scratching up leaf litter or scratching at the bark on trees to get into the termites that are crawling there. But yeah, they don't go after the mounds.
I can see it in my gallery when it comes to
Yeah, so it's assumed that they smell them, so they've got that really long nose and quite tiny ears. So yeah, there's sort of been some researchers before me that have sort of come to that conclusion that they smell like that. Yeah.
Do they need a particular species of termite or?
We fairly generalist within their area. They obviously prefer the ones that live in the sand and that are eating the woody debris. But we've not done a study looking at particular species. Yeah.
if a couple of 100 years ago they were right across the continent, we think they're
Yeah.
not too fast.
Well, yeah, and I feel like if you're only eating termites, surely you don't need to do fussy.
I just wanted to know how they survive the those two particularly those are numbers missing.
In the fenced reserves, yeah, the numbers are increasing. It's obviously fairly slow because they do only have that one breeding season per year. But every time we trap a female and we check the pouch in sort of after breeding time, that we often see them having the full 4 young, which is a great sign. We also see a lot of juveniles on our camera traps, which is also a great sign as well that they're doing really well.
No, that's
Related question to the fenced areas that people are asking about. You mentioned that the fenced areas have been rid of predators or feral predators. What sort of native predators might, there hawks or eagles or other things in there that might want to go for them?
Yeah, definitely owls, birds of prey. I guess even like things like snakes or goannas would go after the juveniles because they are quite small when they're still juveniles. But yeah, we found a deceased numbat that had been predated on by a bird of prey. We sent it off for an autopsy, and yeah, that was the.
So those fenced also put a laser that's still getting through fence or over top of it.
Probably not something as big as a lace monitor, but you do get sand goannas that can fit through the fence, or snakes, and then obviously you can't stop birds from flying in and out. But the idea is not to exclude the native predators, because you would expect that when we want to release them back into the wild, they'll still be dealing with those predators. So you want to keep it as natural as possible, but we are just trying to exclude the invasive predators because that's not what they're used to, and that's really what's causing their decline.
What do you know about their lifespan? Are they like really short lifespans?
Yeah, I don't know exactly, but it's not long. I think maybe like 3 to 5 years. Yeah. Yeah.
Is there any evidence that the increase in temperature is causing any issues in those areas, or are they surviving and changing their behaviour versus will be planned for the future?
Yeah, so it does look like under the current climate, they are surviving by just changing their activity. But we're, I guess, more concerned about under future climates, because at the moment, you know, they've got that inactive period during the middle of the day, which is sort of squashing their foraging windows in the morning and afternoon. And we're just concerned that if it gets too hot and they get squashed, the foraging periods get squashed too small, then they won't have enough time to actually forage and get enough termites to sustain themselves. Exactly, yes, yeah.
Do we know anything about, whether they had staying condition where they're healthier in autumn and spring and lose weight and some? They have the capacity to put on fat reserve.
I don't think that they could put on fat reserves. Like, they're not the sort of animal that will eat heaps, you know, during a nice temperate season and then can store that for later, because they are quite a small animal. And I think, yeah, if they do start losing a lot of weight, it will be concerning physically. We do know that they use torpor during winter. They really don't like the cold, and so torpor is sort of a type of hibernation, where they can slow down their metabolism and slow down their activity, and so they don't have to eat as much, and they can go into that voluntarily for up to this like 24-hour period, but they don't do it seasonally like a bear or something does. Yeah.
Question?
How big is the reserves? How big are they?
Yeah, quite big. So Seeker Rocks is 25,000 hectares, and I think Mount Gibson is maybe about double that.
And the animals that are pulled from that one area. Be populated that.
Yeah, I mean, originally, yeah, they would have come from one of those wild populations, and then they've got a breeding program at Perth Zoo where they breed up the Numbats and sort of distribute them to the different fenced reserves. And then we also sort of, you know, swap around some species sometimes just to mix up the genetics. Yeah.
It seems to me that I would separate and start with them, feel that, you know, the project will back on that's a leverage. And there's what this well, that's about. Some community is it true is the main problem. I don't know about the professor. We should be like profile of the page.
No, I definitely think that they have a bit of a low profile. And I think I really realized that coming into this PhD, and I tell people I'm working on Numbats and they're like, what is that? Yeah, which is a shame because they are such great animals. But I think because we have, you know, so many native mammals, particularly so many native mammals that live in deserts, and so many of them are threatened. So it's hard to really, you know, get everyone excited about every single one of those animals and trying to protect every single one. So yeah, there's probably a lot that the general public that doesn't work in that sphere, they probably wouldn't know about, you know. Exactly.
Be the brain for
Like a home range. Yeah. So they're actually quite tight little circles, which is great for me because once I sort of figure out their home range, you can go and radio track them really quickly. But it's maybe only like a few Ks squared. Yeah.
you know, we're in WA.
Yes.
So there's two like eating, which could be.
Yes, there is. Yep. Yep. Yeah, if you go to Diurnal in WA, you will see both Numbats and echidnas. Yeah. But they don't seem to have too much of like a competition effect on each other. I think there's enough termites to go around.
Any more questions?
This is my last one, and maybe where you'll get to, as you said, they're the only member of the family that still exists. How far back in the history of that goes on? Other members of their family, do we know what happened?
Oh. Yeah, I'm not sure I know the answer to that one. Yeah, I think it would be quite far back. I know that their closest relative is the thylacine, which yeah, which you can kind of see it when you look at them. They're kind of just like a small thylacine, but yeah, the thylacines are also extinct. So
Just my thought on.
Okay, make sure it's on.
Long presentation.
This for you, Courtney. You can.
oh, I'm sorry.
Stand the other side, you did.
Okay. So, yes, Courtney, thank you for a fantastic talk on Numbat, such a gorgeous animal and one of our most attractive native animals. And I'm pleased to say that I've had the lucky experience to go to Drayandra, which I recommend to anybody. It's the most beautiful reserve, and seeing the Numbat in the wild. We drove around for a few hours and we found the wild. So we were incredibly excited about that. And it's great to see people doing some work on some of our really unique things that aren't in vast numbers. And if we don't know more about them, they might disappear off the planet, which would be incredibly sad. So thanks so much for your work, and let's hope that we see a population explosion of Numbats.
And as an extra thank you, we'd like to give you one of the off calendars. Some beautiful picturesque photos of the local environment. And, thank you very much from all of us, and keep up the excellent work.
Yeah.
Thanks again.